So what we have here, folks, is a simple demonstration. We've got a beaker full of clear water, a little bit of milk to pollute the water, and then of course we're shining that through an overhead, through a black piece of paper with a hole cut out at the bottom. And of course, as you can see, the image that we're seeing right now is a fairly clear circle of light. What we're going to do is pollute the water the same way the air gets polluted, if you like, not really polluted, but filled with all kinds of things like dust and pollen and smoke. Here's a beaker of water and a small beaker of milk ready for our demonstration on why is the sky blue. You can see that from the overhead projector, the light is being shone up. It's going through a circular hole in the underneath the beaker, and you can see a shaft of light coming up, and that shaft of light looks fairly white, all right, because all the white light is blended together. And if we take a look on the overhead, we see that the image is actually white as well. All right, so now what we're going to do is we're going to add a little bit of milk to this beaker, and then we'll see what the effects of adding particles into the atmosphere, in this case the water, has on the scattering of light. The theory is that the shorter wavelengths, such as blue and violet, will be scattered more than the longer wavelengths, such as red and orange. So before we add any milk, you can see that the shaft of light is relatively clear. There's even a little bit of scattering from the material that's in the water. You can see there's a slight blue tinge, but you can see that the image that's produced seems to be composed of all colors. So we'll just add a couple of drops of milk. These particles of milk will be suspended in the water, and they then will affect how the water refracts or disperses the light. The water seems to have gotten a little more blue too. You can see on the sides of the shaft of light that's coming up from the circle that on the sides the water is blue, and then when you look at the image of the projected light, the light has become orange. That's because the wavelengths of blue light and red and orange light are different, and the shorter wavelengths are scattered more. That is, the shorter blue wavelengths and the violet wavelengths are scattered more than the red and the orange and yellow wavelengths. So we'll just add a little bit more and see what the effect is. You can see that the blue is appearing to come up from the sides compared to when you look down to the top. You can see that the light coming from the top is quite dark red. Alright, so the light of a longer wavelength is allowed to go through, where light of a shorter wavelength, that is the blue, is dispersed. Here's a good shot of the red. As we move away, we can see from the side view it's the blue. So the light coming from the sun goes through the atmosphere, goes through the many particles. The long wavelengths are not scattered, so they come through to us. We see the sun as being yellow or orange, and we see the sky on the sides as being blue. When we look at the sun through a smoky haze or fog, we see the dispersed light is going to be blue. That's why the sky is blue. And then of course when we look at the ball of the sun, since the blue light has been scattered, the sun appears to be orangey red.